Hey guys, this is the second of 3 videos. The first video just showed you how to simplify radicals. I hope it helped. If it didn't, find other videos on YouTube. Ask the teacher when you get a chance. Do not accept defeat. Please do not accept defeat. Okay, so this is the second video. I'm assuming you already know how to simplify radicals. So please, if you do not, go teach yourself before you watch this video because you will be confused. Here we go. The first thing you do when you have to add, subtract, or multiply radicals is you see if you can simplify the radicals even further. In this video, I'm just going to show you addition, subtraction, and multiplication, and I'm going to have division, and it's in the last video. And a little cool trick at the end. Alright. 6 is 3 times 2. It's already broken down. It's already simplified. Square root of 6 is 3 times 2. I can't simplify it anymore. There won't be any marriages going on here. There is not a perfect square that is in 6. So it's already simplified. This is awesome. This is like the best type of problem you can wish for. Since my radicals are already simplified, all you have to do is check to see if they are the same. If they are the same, you know that you can actually add them. If they're not the same, then you just leave it alone. It's already simplified. So you add the numbers up front because there's addition there. If there was subtraction, you would subtract. Add the numbers up front. 5 plus 8. 5 plus 3 is 8. And then you just write the radical that they had in common, the square root of 6. That is it. I am not making it more simple than it already is. There it is. This was your first example. Here's your second example. Let's say I have 5 square root of 6 plus 3 square root of 15 minus 2 square root of 6. Yes, I can give you as many as I want. The first thing you do is you try to see if you can simplify the radicals. 6, we already know. I already just did it. It's 3 times 2. You cannot make it any simpler than that. There are no marriages. There's nothing you can do to simplify it. Let's look at the square root of 15. It's 3 times 5. Can't really do anything with that either. So you can't simplify the radicals anymore. Now all you have to do is say, okay, are the radicals the same? I can add them if they're the same or subtract. And then if they're not the same, I can't do anything with them. Ooh, these two are the same. This one here, not so much. So what I'm going to do is I'm going to add these two, and then I'm going to just write that one behind it. So, what is 5 times 2? 5 minus 2. I apologize. 5 minus 2 is 3 square root of 6 because that's what the radicals were. And then I just write this because I couldn't simplify it anymore. That's your answer. Questions? I don't know why I just asked that. It's a video. You can't really ask me questions. If you have a question, rewind the video. Re-listen to what I said. See if you can catch it the second time. And then if you can't, ask me in class. Think about it. The way I do is I think about it as variables. So honestly, what I do is I think about it as, okay, if they have the same radical, they're the same variable. So I'm going to make these x's. This is a different radical, so this will be a y. 5x plus 3y minus 2x. Well, I combine my like terms. 5x minus 2x is 3x, and then plus 3y. That's really how I think about it, but mathematically that's what you do. Whatever floats your boat. Think about it however you need to think about it, as long as you get the right answer every time. Example 3. Example 3. first thing you'll do, simplify the radicals. After you simplify the radicals, what you'll do is see if they have the same numbers under the radicals. If they have the same number under the radical, great. Add them, subtract them. If they do not, you leave it be. Can I simplify square root of 24? Why, yes, I can. It's 6 times 4. 4 is a perfect square root. The square root of 4 is 2. So really, what I have is 5 times the square root of 4, which was 2. And then under my radical, I still have that 6. Okay. Over here, can I simplify the square root of 54? Well, let me see. That's 9 times 6. Ooh, perfect square. Square root of 9 is 3. So what I really have is 3 out front. The square root of 6 still left inside. If this is confusing you, then you need to do what I showed you in the first video. You need to break it down, then break this down, keep breaking it down till it can't be broken down anymore. I'm using my shortcut method. If you need help, do it the long way. No one's judging you. Well, I'm judging you, and I'm judging you on if you get the right answer. So hey, if you take a little longer to get the right answer, but you get the right answer, I'm okay with that. Alright, so this turns into 10 square root of 6 minus 3 square root of 6. They're the same. Since they're the same, I add the numbers up front. Well, in this case, subtract them. 10 minus 3 is 7. I keep the same number under the radical. This is my answer. Alright, next example. Pause it. See if you can do it without me. I know you can if you really understood everything we did so far. You don't need me. If you do not understand something we did so far, then pay attention to me as I do it now. This is your last chance to pause it before I start cracking. 24. I'm going to do it the long way just so you can see it. I'm not going to do it the shortcut way I just did. Oh, sorry. Didn't know you could see it. I'm going to do it the long way. Just for those who need it, who needs to see it the long way. Alright, so I'm going to break down 24. I'm going to use different numbers now because I can. 12 times 2. Can I break down 12 anymore? Yes. 3 times 4. Can I break down 3 anymore? Nope. Can I break down 4 anymore? Yep. 2 times 2. If I'm moving too fast for you, pause the video. This is your time. So this turns into 5 square root of 3. I'm going to move it down a little bit. Times 2 times 2 times 2. Let's see. 24. Let me just check it in my calculator to make sure that I didn't mess up anything. 3 times 2 times 2 times 2. Got 24. I did it right. Alright, so now square root. I'm going to circle 2 of them. Remember, that's because there's an imaginary 2 right there. If there was a 3, I would need to circle 3 of them to bring out as 1. In this case, I need 2 as 1. Okay, so yep. 2. Don't have anything else to marry, so I end up with 5 times that 2 square root of what was left, which is 3 times 2. So I really have 10 square root of 6 minus, I can't break that down anymore, 2 square root of 3. Can I combine them? Are the radicals the same? No, they're not. Since they're not the same, that's my answer. 10 square root of 6 minus 2 square root of 3. It is simplified. Alright. Next example. Example 5. Okay. Let's go to multiplication. I'm done with adding, subtracting. There are no tricks really. If you understand what's going on, you understand it. Let's go to multiplying. Multiplying is different than adding and subtracting. With multiplying, you don't really care if they're the same or not under the radical. You multiply what's in front, you multiply those coefficients, you multiply what's behind. That's all you do. So, let's get started. First step is the same. See if you can simplify these. I'm not doing this again, guys. I'm telling you right now, you cannot simplify the square root of 6. It's already simplified. So what you're going to do is you're going to multiply the numbers up front, multiply the numbers under the radicals. What is 5 times 3? What is 6 times 6? Then at the end, you always see if you can simplify anymore. Can you simplify the square root of 36? Yes. The square root of 36 is perfectly 6. So you end up having 5 times 6. So your answer, 15 times 6. Your answer is 90. I'm saying this stuff is simple, but that's because I understand it. If you're feeling like it's not simple, that means you're not understanding something. So stop the videos, go back to the part that you last understood and start playing it from there. It is simple. I'm not saying that it's complicated. I'm not saying that everyone will get it. Everyone will get it if they really understand what's going on. Okay, so let's go to the next one, shall we? 5 square root of 6 times 3 square root of 2. Oh no, I'm freaking out. I'm looking to see if I can simplify these. I can't. Square root of 6, you can't simplify. Square root of 2, you can't simplify. So I'm like, oh no, they're not the same. So that means that that's the answer. And I'm wrong because I'm not adding or subtracting. I'm multiplying. I don't care if these are the same. I'm going to multiply the numbers up front, multiply the numbers under the radical, and then I'm going to see if I can simplify it again. So 5 times 3 is 15. Square root of 6 times 2. 6 times 2 is 12. I'm going to see if I can simplify that. Can I? Yes, I can. Okay, the square root of 4 is 2. So really, I have this 15 times this 2. And then under the radical, I have this 3 still. Alright, 15 times 2, 30, square root of 3. That's my answer. Last example. This example, ridiculous. This one is not simple. All the other ones, I'm like, okay, if you understood what was going on, you're awesome. With this one, if you get lost, okay, it's not because you don't understand, it's because it's different. But I'm telling you right now, the steps are the same. If you understood what we were doing in the past, this one you can understand. Might not be the first time you see it, but you can understand it. You might have to replay it 2 or 3 times, but you can understand it if you understood what was going on so far. Here we go. Do not freak out on me. Okay, here we go. That is the challenge. Alright, so we can do this. The first thing I'm noticing is, whoa, what is this right here? It means I don't have a square root anymore. I have a cube root. I have a cube root. So instead of circling groups of 2 when I put my radical and prime factorization form, I'm going to circle groups of 3. That is it. That is the only thing that's different. Oh wait, I have a variable right there. I'm not freaking out. Same thing, circling groups of 3. Here we go. (32) is 16 times 2. You might think, oh, perfect square. I don't care about squares anymore. I'm thinking about cubes here. So what you could do, if you wanted to be advanced, is you can do 8 times 4, because this is a perfect cube. 8 is 2 times 2 times 2. That is beautiful. So I already know that once I finish doing it, and I'm going to do it the long way, you're going to see that I have 6 times 2 with the square root of 4 left over. Okay, anyways, that can be broken down to 4 times 2. That can be broken down to 2 times 2. Cannot do anything with this. Cannot do anything with this. Cannot do anything with this. I can't do something with that. 2 times 2. Can't do anything. Can't do anything. I have 3 P's there. Alright, circling groups of 2. Nope, groups of 3. So, I have 6. I have that times that 2 that just came out of the house, times that P that just came out of the house, and then the cube root of what was left, which was 2 times 2, and then there wasn't anything else. Now listen, this 3 has nothing to do with this 6. Do not multiply them. Do not do anything to it. It's just telling you how many to circle. Keep writing it in the little hook right here. Please do not start combining this 3 and pulling it out. My answer is 12p cube root, I keep writing it in the house, of 4. And then that's just for this section here. Yes, you thought you were done, but you're not. This is still being multiplied by the cube root of 27. So I need to come over here and do the same thing and simplify the cube root of 27. Alright, the cube root of 27. Can't simplify these anymore. So, the cube root of 27 is really the cube root of 3 times 3 times 3. Ha! Group of 3 comes out perfectly. So the cube root of 27 is really 3. So I'm multiplying this by 3. 12 times 3, 36. I still have that P there. And I still have the cube root of 4. This didn't have anything. If it had something afterwards, I'd multiply them together. And then I'd simplify that even more. But this is my answer. If you can do this one, you're awesome. So here you go. What you need to do is rework every single one of these problems and see if you can get to the answers we just went over.